Hi, this video is about experiments, so we will learn some vocabulary around experiments and look at an example. So first of all, in a controlled randomized experiment, and we'll talk about what all these mean, controlled and randomized, researchers assign treatments to groups of subjects. Okay, so we're going to have different groups. We may have different treatments, and then they measure a response variable. So we'll talk about all the vocabulary words. And if the results are significant, we can infer causation. So this is different than an observational study where we cannot infer causation. So we'll talk about why that is. So let me use a different color for that. If the results are significant, we can infer causation. Okay, so to look at a specific example, this study was done on the use of stents. So this is a picture of a stent, which is like this little wire kind of a basket or support that goes in a blood vessel. Okay, so and the question is, does this reduce the risk of stroke? So I believe this has been used for heart patients, and they wanted to know, well, would it help prevent a stroke? So they have 451 at-risk patients who volunteered for the study. Researchers randomly assigned 224 participants to the treatment group and 227 to the control group. They studied the effects at 2 time points, after 30 days and after 35 days. So we're going to use this as our example and talk about the different vocabulary and what's involved. And you may know a lot of this vocabulary from the media or from previous study. So the treatment group, these are the participants who received the stent. So the treatment group, they are getting the treatment, the thing we're studying, whether it's a drug, a device like this, exercise, diet, whatever we're studying. It says they also received medical management, so stent and medical management. The medical management included medications, management of risk factors, and help in lifestyle modification. Okay, so that's the treatment group. So this is the group getting the treatment. Okay, now we also have a control group. Participants received the same medical management as the treatment group, but they did not receive the stent. Okay, so this is the controlled part of the controlled randomized experiment. Okay, so first question, why did the researchers use a control group? You've probably heard about the control group, and also control group often gets a placebo, which we'll talk about down below. Well, let's say they took all 451 patients and they gave them all a stent. Well, then we wouldn't know. We would have a certain success rate, but we wouldn't have a baseline to compare that with. So the control group gives a baseline for comparison. What's the difference in having something, the treatment that we're studying, versus not having it? Okay, so a control group is needed as a baseline for comparison. Okay, if we don't have a control group, we don't have anything to compare with, so we can't determine if it's statistically significant or not. Okay, question letter B. Why is it important to use random assignment of the participants to the groups? How is this different from random sampling? Okay, so let me go back up here for a second and see where this occurred. Researchers randomly assigned 224 participants, 227. So they're not quite equal. They don't have to be exactly equal, but we try to get close. randomly assigned. So this is important because we wouldn't want to say put all the men in one group and all the women in another group, and then where do non-binary people go? That's a different issue. Or we wouldn't want to put all the younger folks in one group and all the older folks in another group, because then age is a variable there. So we need to spread out all of the other variables: age, race, ethnicity, lifestyle, smoking, all those different variables we're looking at. We need to spread them out into the two groups to make sure that it's not another variable that is responsible for the results. Okay, so we need random assignment. Random assignment is used to spread out all the other variables. I'll say age, race, lifestyle, etc., in order to isolate one variable. Okay, now in a previous video we were talking about random sampling, and sometimes these two get mixed up. The other part of the question is, how is this different from random sampling? Sometimes those get mixed up. So in an experiment like this, we often have a certain group of patients, right? And they're recruited, they need to meet certain qualifications. Do you have, are you at risk for this, but are you not too much at risk? Like, there's all these different considerations for being part of an experiment. And so the participants are not chosen at random. But once we have the participants who, like it says, volunteered, they have to have their consent as with anything, then they are randomly divided. Okay, so that's called random assignment. Versus random sampling is if we were going to do a survey and say, call 451 people at random, choose their phone numbers at random. So that's a different type of randomness. Does that make sense? So random sampling is choosing, I'll just say 451 since it's the same number of people at random. This would be used for a survey. Or something that's not an experiment. It could be even if someone was looking at medical records to do some kind of study like that and choosing random medical records, but it wouldn't be, random sampling wouldn't be used for an experiment. Okay, great. Okay, so now another question, was a placebo used for blinding? So placebo, you've probably heard about placebo and placebo effect. A placebo is a fake treatment. You might have heard like a sugar pill. Let's say it was a drug-related thing and this person was taking a drug. Well, if the control group is not doing anything, then there's this placebo effect. Like, well, is it just the effect of doing something, or is it the actual treatment that's doing it? And then what if the placebo group, the control group, if they're not doing anything, then obviously there's some kind of psychological factor there as well. So usually a fake treatment is used, a sugar pill or some inert treatment. Now, how do you do this when you're talking about a stent? You're not going to have a fake surgery or a fake medical device. So I believe that's where the medical management comes in. Both groups are getting the medical management, and the control group is getting the medical management. So they are getting some assistance. And so it depends how the study is phrased, and there's a lot of ethics around this, right? So these folks may believe that that is what is being studied, and then but they've consented to all this, and it needs to be, above board, because there's been some terrible experiments done in the past. So ethics are really important with this. I believe the medical management is the control, is the placebo in this case, because both groups are getting that, but then the difference is the treatment group is getting the stent. Okay, so we could say yes, the medical management should have left a little more room here, huh? Is the placebo. And that's used for blinding. Blinding means people don't know which group they're in. So I might not know if I'm in the control group or the treatment group. That's called blinding. Okay, there's single blind and double blind, but we're not going to go that much in depth with this. I could do a whole course on experimental design. Okay. So now we want to talk about the response variable. Okay, now we're getting to the results. They measure a response variable. So we have the actual result. Oh, this is an actual study. We have the actual results here. You can see we have, instead of cases like we had before where each row was a case, here we have the groups. So we have the treatment group in the first row, the control group in the second row, and then the total. And then in the columns, we have the results. Whether a participant had a stroke in 0 to 365 days, so 1 year, and then whether the number that did not have a stroke. And then here you can see the total in each group, which was the 224 and the 227. And the lower right corner is the grand total of 451. Okay, so what proportion of patients in each group? So we're going to use the wording to determine how to do our calculation. So what proportion of patients in each group? Okay, so that means we're going to look at a row. The treatment group had a total of 244. So I'm going to write that, 224. I'm going to write that as my denominator. And what proportion did not have a stroke? So the first column is stroke, then no stroke. So that's going to be the 179 out of 224. Okay, so I'm going to divide that on my calculator. 179 divided by 224. And I'm just going to leave it in the decimal form, which is a proportion, 0.7991. The next digit is a 0, so I don't need to round that up. So 7991. We could change it into a percentage, but I'm not going to right now. Okay, that's the treatment. So you can think of it as almost 79 or almost 80% did not have a stroke. Okay, seems good, right? I mean, I don't know. We need something to compare that with, right? So control group, that is our next row down. And we're going to look in the no stroke column. What proportion did not have a stroke? 199 out of 227. So 199 out of 227. It seems to be a higher number, but the denominators are different. So let's compare. So not having a stroke is better, right? So higher is a better number in this study. 199 divided by 227 is 0.876. There's another 6 and then a 5. So that 5 is going to round that 6 up. So 0.8767. 8767. Yes, that's right. Okay, well, this is interesting. The control group did better because more people did not have a stroke. I don't think that's what they meant to happen, right? So the question is, did this happen due to chance, random variation, or did this happen, are these results statistically significant? Okay, so that is the question. And we don't quite have the math yet. we could do a simulation for this, and there's theoretical ways to do it. We don't quite have the math to do this yet. So I'm just going to write down the questions here. So the question is, does it look like the results of this experiment are statistically significant or due to random chance or random variation? So that is always our question, right, when determining statistical significance. So I'm going to write the control group did better, which is surprising. So further study is needed. Right? The researchers need to figure out, is that stent doing harm in some way, or was it just due to random variation of the difference in the folks in the different groups? So definitely further study is needed. We might want to look at, in the future, we'll look at the difference between two groups. So if I subtract, I already have the second one in my calculator. So if I subtract the first one, 0.7991, the difference is 0.0775. I'm just going to round that to 0.08 or 8%. The difference is about 8%. And we're not sure yet whether this is due to random chance or is statistically significant. Okay, we don't have, oops, let me move that up. We don't have the tools yet to know for sure. It has to do with sample size and some other things. So we don't have the tools yet, but for right now, I want you to understand this concept of what we're deciding between is, are the results due to chance or are they due to something significant going on, statistically significant? Okay, great. So I hope that gives you an idea, a sense of the different experimental vocabulary we'll be using, and you can practice with the rest of the course materials. Okay, I'll see you in the next video.